Information security is frequently taught to students as an endless, overwhelming glossary of isolated vocabulary terms and acronyms. But if we look at standard certification material, like the practice questions for the CISSP exam, we can extract the underlying logic of enterprise security. Most engineers study firewalls, network protocols, and operating system kernels as isolated, separate domains. This first artifact is a raw snippet from a Windows firewall log. This second artifact represents the standard diagram for transport layer protocol establishment, and the third illustrates the concentric protection ring model of execution privilege. While these appear distinct, they represent the successive layers an external signal must pass through to interact with the CPU. These are sequential validation gates. Modern security relies on a series of decreasingly permissive domains. Mastering this architecture requires knowing where the network perimeter ends, where protocol trust begins, and how the execution environment isolates malicious code. We begin at the network perimeter. Question 9 from the CISSP practice test asks us to identify the type of attack shown in this Windows firewall log. Looking at the far left column, the firewall is taking a consistent action, drop TCP. It is actively blocking incoming connection attempts. The logs show these attempts are flowing from a single source IP address targeting a single internal destination. The pattern is revealed in the destination ports. With every request, the port number increments by exactly 1, 4004, 4005, 4006, continuing up to 4011. This sequential probing of destination ports is the signature of a port scan. The firewall is acting as gate 1, comparing every incoming packet against predefined rules and silently dropping anything unsolicited. By dropping these packets at the edge, the firewall protects internal systems from having to process or respond to illegitimate requests. Perimeter defense prioritizes resource preservation. It stops reconnaissance before the target machine has to commit CPU cycles to a response. But if a port scan finds a gap, an open port allowed through the firewall, the nature of the interaction changes. Question 5 asks what System B sends at step 2 of this connection process. This is gate 2, the transition from perimeter filtering to protocol establishment, executed through the TCP three-way handshake. At step 1, the client sends a SYN packet to initiate a connection. To respond, the target server must acknowledge the request and synchronize its own sequence numbers, sending a SYN ACK packet. At step 3, the client confirms with a final ACK packet. This handshake represents a critical inflection point for system security. Completing the handshake forces the target server to allocate physical memory in its RAM buffer to maintain the connection state. At the transport layer, an attacker upgrades from sending stateless packets to a committed resource relationship with the target server. Once the connection is established and a payload is delivered, the final barrier is the execution environment. Question 37 asks which ring in this model contains user programs and applications. Gate 3 is defined by the operating system protection rings, a system of hardware-enforced isolation. Ring 3 is the outermost domain, often called user space. This is the restricted area where user applications and incoming network connections are contained. The innermost core is Ring 0, or kernel space. Code running here has unrestricted access to the computer's CPU and memory. Hardware constraints dictate that code in Ring 3 cannot directly interact with physical memory or Ring 0. To perform a privileged action, a Ring 3 application must use a system call. This forces the kernel to inspect and verify the request before execution. OS architecture is the final gate. It restricts what a successfully delivered network payload can achieve, unless the attacker finds a path to escalate privileges. We can now align these three concepts to see the end-to-end architecture of validation. A successful compromise requires navigating this entire sequence, piercing the firewall, establishing a TCP connection bridge, landing in Ring 3, and finally attempting to reach the Ring 0 kernel. Port scans map the perimeter, handshakes establish a foothold, and privilege escalation bypasses ring isolation. The value of the CISSP curriculum isn't found in individual answers, but in the visualization of these interlocking layers. Security expertise is the ability to see how these isolated mechanisms combine to create a unified defense-in-depth architecture.